Hello everyone. This week we are going to be looking at the topic of simultaneous equations. Thank you for those people that emailed me as to which topics you want me to cover. This one came out kind of up on top. If there's other topics you'd like me to make a video about, anything at all, please say, because we're just going back over the topics really that we did in year 10, and the same pattern is continuing in school. Your fourth lesson, or whichever lesson that is, in school will be the circle theorems. That's going to continue on. Thank you for all those people that did the Google form test. For those of you that haven't done it yet, please can you make sure you do it at some point. If you're struggling to answer the questions, just do the ones that you can really. But it's a way for me to keep track of what you can do, what you've understood. So it's really helpful for us teachers to kind of see what you're kind of doing. So please make sure you have a go at it. And once everyone's done it, I will release the scores. Okay, so thank you very much. So this week we're looking at simultaneous equations. In this video, we're going to look at the bog standard simultaneous equations, the ones that you did in year 9, and we'll look at some algebraic and wordy problems, and we're going to look at the elimination method that you were probably taught in year 9. The second lesson this week, we're going to look at the harder non-linear simultaneous equations. Now those are quite tricky and they're very algebraic and they involve quadratics, so we'll do a bit of recapping on that. And then the third lesson is some problems for you to have a go at. Again, I'm not going to set loads of questions for you to do, but just one or two, a 4 or 5 for you to have a go at. And that's the third lesson is the one I want you to submit, okay? And the fourth lesson is circle theorems continued. Okay, so in this video we're going to look at methods for solving simultaneous equations and algebraic and wordy problems, and then these are the questions that you should have a go at from Caboodle. Again, you don't have to do all of the questions, you can do however many you want. Exercise 39 is kind of just algebraic problems, and exercise 40 is kind of like wordy problems where you have to analyze and read the question. Okay, so we're going to look at solving simultaneous equations using the elimination method. Okay, now here's a simultaneous equation. What a simultaneous equation is, it's where you've got two unknowns. So what I mean by that is the letter x and the letter y represents two numbers that you don't know, and you have to figure out what they are in such a way that they work in both of these equations. So whatever x is, whatever y is, if I put it into the first equation, it should give me 8. And if I put it into the second equation, it should give me 7. Now, in this particular question, you could probably quite easily guess what the two numbers are. They're not very difficult. But in certain other questions, it can be a bit tricky and you can't always guess what they are. And you have to do a bit of working out, which is what I'm going to teach you now. Okay, so the elimination method, how does it work? Okay, what we need to do is somehow eliminate one of these letters. It doesn't matter whether you eliminate the x's or the y's, but you kind of need to get rid of one of the letters. And what we're effectively going to do is we're going to add or take away these two expressions. Now, but before we do that, what we need to do is look at the numbers in front of the letters, okay? And they're called coefficients. So for example here, the coefficient of y is 2. Here, the coefficient of x is 2. So that's just the number in front of the letter. Now, these two letters don't have a number in front of it, but when there's not a number written there, it's 1. So this is just 1x, and this is positive 1y. Okay, so what we need to do is look at the numbers in front, and we need to try and get it so that the numbers in front of both letters are the same. So now you might remember this from year 9. It's not particularly difficult, but what we need to try and do is get the numbers, the coefficients to match each other. And you do that by multiplying or even sometimes dividing the equation by something. So what we're going to do is we're going to decide which letter we're going to try and get the numbers to be the same for, the coefficients to be the same for. So what I'm going to do in this one is I'm going to try and get the y's to have the same number. Now, by the way, when I say number, I don't really care about the sign. Okay, so I don't really care about the positives. So if one was positive, one's negative, I don't really care about that. I just care about the kind of the number in front. I want to try and get that to be the same. So what I'm going to do is on this one, I'm going to keep the top one the same. Okay, so I'm going to keep that one the same. I'm not going to modify that one. So I'm going to copy that over. but the bottom one, I'm going to times it by 2. Now, when I say times it by 2, I mean I'm going to times everything you see here by 2. So that's going to give me a 4x. Okay, so that I'm going to times that one by 2. That's going to give me a positive 2y. And then I'm going to times I'm going to times this by 2 as well. So everything by 2. So that's going to turn into 14. Okay, now notice what we have here when we double the bottom one. We have a 2y and a 2y. We've got the coefficient to be the same for the y's. Okay, now I don't care about the sign. It's really just to do with the number in front of that letter. I want to try and get it the same. Okay, now we're going to do this thing that what I mentioned, the elimination. Now we're going to eliminate the y's. We're going to get rid of them. Okay, and what we do is we look at the signs in front. Okay, and they're both positive. Okay, and what we say is this: is if the signs are the same. So after you got the numbers to be the same, if the signs are the same, subtract. Okay, so that means if they're both positive like this, which they are, then take away, or if they're both negative, then subtract them from one another. So what we're going to do is we're going to subtract. Now I need to kind of delete some of this, so give me a second. Okay, so I'm going to subtract these two expressions. So I'm going to do like a little line here, and I'm just going to take away these two things from each other. But the way I'm going to take them away is I'm going to do the top, take away the bottom. Now, you can easily switch these two expressions around, so you could write this equation, this one on the top and so on, but I'm not going to bother. I'm literally going to take them away. So I'm going to do 8, take away 14. That's going to give me minus 6. Okay. Now, this is why it's called the elimination method, because when we do 2y, positive 2y, so positive 2y, take away positive 2y, then what happens? Well, effectively, they cancel each other out. They eliminate one another. So 2y, take away itself, is 0. So basically, this thing here is gone. They're gone. They're eliminated. But we need to carry on. So they're gone. So x, take away 4x, is minus 3x. Okay. So what we have is a smaller equation. We've eliminated, i.e. elimination method, we've eliminated the y's, okay? But the idea is you need to try and get that number to be the same for both equations. You need to try and get the number to be both the same. So you can keep one the same and double the other one, or you can times them both by 3, or you can times one by 3 or the other by 2, but you try and get that number to be the same. So we've done that, and then we just basically take them away. Okay, so now we've got to solve this mini equation. Now look at this mini equation. Minus 3x equals minus 6. Now it's easy to work out what that is. You don't even need to do any working out. But I'm going to do the proper algebra. I'm going to divide both sides by negative 3, because that's what the opposite of multiplying by minus 3 is. So minus 3 is multiplying that x. So the opposite is to divide. So I'm going to take minus 6, divide it by minus 3. Two minuses when they divide make a plus. So the answer is 2. So we now know x is equal to 2, okay? But we need to still find y, okay? We know x is 2, but we don't know what y is. Now the thing is though, the great thing is though, we've got an option of 3 different equations to use. You can use this one, or this one, or this one. So either one of these equations you can use. Now you might remember this from year 9. You just got to take this value of x and sub it into one of these equations to work out what y is. I'm going to sub it into this one here. So I'm going to use this one. Okay. So I'm going to replace that x with 2, because I know it's worth 2. So 2 times x, so 2 times 2 is 4. 4 add y equals 7. I'm going to take away 4 from both sides, so y equals 3. So this is what y equals. So don't forget to write your answers in a neat way. So here they are, written out neatly. Oops, okay, let me write them again. X is 2, y is 3. Now, I'm just going to, so this is the answer, but I'm just going to double check that it works, okay? So I'm going to put these two numbers into the first equation here, and that should give me 8. So 2 plus 2 times, sorry, I've written it wrong, 2 times 3. Okay, so that's 6, add 2 is equal to 8. So that works. Okay, I'm going to put into this one, which it should work, but 2 times 2 plus 3 is equal to 7, so it works there. So we know that these two are definitely the answers. Now, if you get a really tough simultaneous equation question and you're not sure if you've got the right answers, a good way is just to sub these two numbers into the equation and make sure they come out to these. Okay, right, let's do another one. Okay, this one here is a bit harder because on this one we kept the first equation the same and changed the bottom one. Here we're going to have to change both of them. Now what I'm going to do is I'm going to, this time around, instead of getting the y's to be the same, I'm going to get the x's to be the same. So I'm going to change it so the x is the same. And literally it does not matter whether you do the y's or the x's because the answer is going to be the same anyway. But just for this argument's sake, I'm going to get the x to the same. So what you could do now is pause the video and see if you get the same working out as me and same answers. So you can pause the video now. Okay, so I'm going to go through the answers. So this is what we're going to do. Okay, so I'm going to times the top one by 4 because what I want to do is I want to make that into a 12. It's a bit like common denominator on fractions. So I'm going to times the top one by 4. So I'm going to have a 12x plus 20y equals, sorry, whoops, not that, equals 8. Don't forget to multiply everything by 4. The bottom one, I'm going to times it by 3. Now, remember I said to you, I don't care about the sign. I just care about the kind of the digits, the numbers. So I'm trying to get a 12. So I'm going to try and get a minus 12 here. So if I multiply it by 3, I get minus 12x plus 21y equals, what's 3 times that? Minus 90. Okay, so this is the equation so far. Now, because we're trying to eliminate the x's, we need to look at their signs. Okay, so here the x's are positive, but here it's a negative. Okay, so well, actually it's just the sign difference. That's a positive 12 and a negative 12. So the signs are different. So here's the rule. Okay, so if the signs are the same, i.e. they're plus, or minus, then we subtract always. But if the signs are different, then so if one's plus, one's negative, or vice versa, then we add. Okay, and you'll see why in a minute. So what we're going to do is we're going to add these two expressions together. Okay, so if we add down, literally just adding down. Okay, so let's start with this one here. So 80 add minus 90, okay, or 80 take away minus 90 is kind of the same, isn't it really? Is minus 82. Okay, so that's that done. Okay, 20y add 21y, and they're both positive, give you 41y. But this is elimination method, okay? We're trying to eliminate a letter. So it should eliminate itself. So 12x add negative 12x, well, they just cancel each other out. They're eliminated, they're gone. So that's the idea. We're trying to eliminate it. Now, because the signs are different, when you add them, they just cancel each other out. They just disappear. So what we need to do is solve this mini equation. So what we need to do is take minus 82 and divide it by 41, which lo and behold is negative 2. So that's what y is. Y is negative 2. Okay, so we still need to find x. So what I'm going to do is going to put it into one of these equations. Now you've got the option of 4, you've got the original 2 or the new ones here, but they're all going to do the same thing. I'm going to use this one because that's probably the easiest one. I'm going to replace that y with a minus 2, so it's going to be 3x plus 5 times minus 2 equals 2. Okay, so 5 times minus 2 is minus 10. So it's 3x take away 10 equals 2, so I'm going to add the 10 over, so that's going to give me 12, and then that equals 3x. I'm going to divide both sides by 3, that gives me 4, so x is equal to 4. So there are your answers for both letters, and it's always a good idea to check. So what I'm going to do is I'm going to sub that into the bottom equation and make sure it gives me minus 30. So I'm just going to double check that. So minus 4 times 4 add 7 times minus 2, let's work that out. Minus 4 times minus 4 is minus 16. 7 times minus 2 is minus 14. If I add those two together, I do get minus 30. So that works, so these two have to be right. Okay, here's a question for you. This one's a tricky exam question. Have a go at it. Pause the video now. Have a go on your own. See if you get it right. Okay, so this is the answers. So the answer is x is 3 1/3, or 3 1/3, or you could put 10 over 3. That would be acceptable, I think. And then minus 2 is for y, okay? Now, if you're not sure how to do it, what I would do first is, I don't like fractions in simultaneous equations, so I'm going to multiply everything by 3 first, just to get rid of that annoying denominator there. So I would just times it by 3. Okay, and then I'll just copy the other one underneath. And then what I'm going to do is I'm going to keep the top one the same, but I'm going to double the bottom one. Okay, so maybe I should have done that to begin with, actually, if I thought about it. So I'm going to double the bottom one. So I'll keep the top one the same. I'm going to double the bottom one, so I'm going to double all of that. So that's going to be 6x, take away 8y equals 36. Okay, then I'm going to eliminate the x's. They're both positive, so I'm going to subtract. So 2 take away 36 is minus 34. 9y take away, now this is where it gets a bit tricky. 9y take away minus 8y is positive 17y. Okay, so if you got it wrong, maybe that's one thing that you didn't realize, because you're subtracting these two. Two minuses make a plus, you're subtracting the bottom one, so you have to be really, really careful. Dividing both sides by 17 gives y is minus 2, which is correct. That's the right answer. Okay, and then sub that into, which is the easiest one to sub it into? Probably this one here, actually. It doesn't matter, but let's just put it in that one anyway. Let's delete that. Delete all of that. Okay, so put that in there. So 6x plus 9 times minus 2 equals 2. That's minus 18 equals 2. 6x, I'm going to add the 18 over, that gives me 20. 6x, I'm going to divide both sides by 6, that's 20 over 6, which simplifies to 10 over 3, which is the same as 3 1/3. Okay, so that's our x. Okay, done. Okay, just one more question before we stop. Have a go at this wordy one. Okay, let's see if you can do this wordy one. So pause the video and see if you can turn this kind of paragraph into some algebra, and then see if you can solve it. Okay, so pause the video now. Okay, so this is the work solution. So by the way, it doesn't matter what letters you use. I just basically use A for an adult ticket, C for a child ticket. So 2 adults plus 1 child is going to make 23. So here's the algebraic equivalent. 1 adult plus 2 children has got to make £17.50, and here's the algebra for that. And then I just solved those equations and worked out that 1 adult ticket costs £9.50 and 1 child ticket costs £4. But make sure you read the question fully, because then it asks how much must you pay for 2 adults and 4 children, and the answer is £35, and I hope you got that. Okay, thank you very much, guys. I hope this kind of makes sense. It's probably a good idea now to have a go at those caboodle questions, and thank you very much for watching, guys.